Okay, so we just covered raw data and organizing and graphing qualitative data as opposed to quantitative data. So we talked about we were focusing on variables that are what we called categorical variables or qualitative variables. Like we had stress, and then there were like three different possible values, right? There was high stress, medium stress, and low stress, or no stress, or something like that. And so we called those high, medium, and none, or whatever it was. We called those the different levels for the variable called stress, or we could just say the different values for the variable called stress. And then we talked about making a frequency distribution for that, and a bar chart and a pie chart for all four qualitative data. So that's what we did. Okay, now let's look at this. So now we're going to try and do the same kind of thing for quantitative data. So you have to do it a little bit differently because the values of the variables are kind of different, right? When you have a quantitative variable like the time that you have to wait at the bus, right? That's could be, so many different possible values. You could say 1 second, 2 seconds, 3 seconds, but you can also say 1.2 seconds or 1.22 seconds. So you have so many different values. So you really have to, it doesn't work out quite as well, or not in quite the same way. So like, if you, let's say, take that example, suppose the time that you have to wait for the bus, how are you going to make a frequency distribution for that? Because no two people are going to have to wait exactly the same time, right? If you measured it perfectly, maybe one person had to wait, 320 seconds, 20.22289999994 seconds. The other one had to wait 0.22289999997, right? So not going to be exactly the same. So you can't say, any one number is going to occur more than once, right? So frequency, counting up the number of times, is not going to make sense or not going to work. So how do we handle that if we want to have some kind of frequency distribution for a quantitative variable like that? So they say here, how about if we take the weekly earnings of employees at a large company? So what they do is they form intervals for the values of this variable. So weekly earnings is the variable. So weekly earnings here is the variable. And what they do is they form intervals. So they form the interval between $801 to $1,000, between $1,001 and $1,200, $1,201 to $1,400, and so on. So they form these intervals. Now you're going to get repeated occurrences of something in here, right? You might get one person that earns this amount between here and here, and you might get another person. And so they say, well, they got 9 people in there, and they got 22 people in here, and they got 39 people in here, and they got 15 and 9. And okay, so now we can get frequencies more than just one per value. So we can get 9, 22, 39, and so on. And so we can basically now do the same kind of thing that we did before, like make a bar graph and so on. This is basically the same kind of picture we had before, so we can make a bar graph out of this. Because actually, if you think about it now, whereas before we had so many different possible values that it could be, like when I was talking about the bus waiting time, but here really there's only 1, 2, 3, 4, 5, 6, right? Basically only 6 values. So that's really like a categorical variable. So we took a quantitative variable and really transformed it into a categorical variable, and then we can do the same things that we did before. They give a little explanation of how should we break up, how should we create these so-called classes. This is the class from here to here. This is the class from here to here. This is the class from here to here. And so how should we create them? Why didn't I say make the first class from 801 to 1200? Or even 801 to 1400? Well, you could have. You could make the classes any way you want, actually. But sometimes they like to say there's some basic rule of thumb for doing this. But really, you can do it any way you want, but let's see what they say. For quantitative data, the frequency of a class, of the class, represents the number of values in the data set that fall in that class, of course. Each class has a lower limit and an upper limit, so 801 and 1000, lower limit and upper limit. So, of course, we don't want to have, if this is 1,000, this shouldn't start at 1,000 because then you might have someone being in both classes. It's not really good. Okay, so frequency distribution for quantitative data. Frequency distribution for quantitative data lists all the classes and the number of values that belong to each class. Data presented in the form of frequency distribution are called group data because we grouped it now. We made a group from 801 to 1000. We made a group from 1001 to 1200, and so on. So we can call it grouped data. Okay, now for the 1000 and 1001, in other words, back here, this number and this number, of course, we can find the midpoint between those two numbers, which is obviously 1000.5. Right? So you just take 1,000 plus 1,001 and divide that by 2. You get 1000.5. And that's called the upper boundary of the first class and the lower boundary of the second class. By using this technique, we can convert the class limits of table 2.7 to class boundaries, which are also called the real class limits. So here, the class boundary is between these two. Okay? Class boundary is given by the midpoint between the lower limit, the upper limit of one class and the lower limit of the next class. Okay, so that's called the class boundary. And what we mean by the class width is just this. The width of the first class is you go from the upper boundary to the lower boundary. So and go from 1000.5 to 800.5. So in other words, it's just the number between here and here and the number between this and the previous one. Or I guess you could also go say the number between here and here is what? Is 1200.5, and the number between here and here is what? 1400.5. So you take that, the 1400.5 minus the 1200.5, that would give you 200. So you'd say that's the class boundary. I'm sorry, yeah. Sorry, no. That's the class width, sorry. Okay? Okay, now next is if you take the lower limit and the upper limit, like 801 and 1000, and you want to find the midpoint in there, then you can just add those two and divide by 2. The midpoint between here and here is 900.5. Okay, so it's this plus this over 2. So it's halfway between here and here. So here they have the class limits, 801 to 1000, the class boundaries, so-called class boundaries, 805 to 1005, class width, and the class midpoint. Okay. I mean, I'm not that personally concerned with all of these definitions, but maybe other teachers that you might have in the future are, so it's going to be good for you to learn this. Not because of me, though. Note that in Table 2.8, when we write the classes using class boundaries, we write to less than, to ensure that each value belongs to one and only one class. So that's, we don't want to have, so we write it like this. So it goes from here to less than this point, and then it goes from here, which is this one, to less than this one. Because we don't want to have one person, for example, in two classes. Okay. So like we said, when we make this frequency distribution table, they said we need to make the following three major decisions. Okay, we need to decide the number of classes. So are you going to have 3 classes or 5 classes? They say usually it's between 5 and 20. Okay? It's preferable to have more classes as the size of the data set increases. The decision about the number of classes is arbitrarily, that means just at random, made by the organizer. So I mean the organizer doesn't have to follow any rules in making this decision about how many classes. The class width. Although it is not uncommon to have classes of different sizes, most of the time it is preferable to have the same width for all classes. Now that's what I usually believe. Usually it's not, you don't have to, but generally it seems more natural to have the same size, the same class size, class width for each for all the classes. To determine the class width when all classes have the same size, first find the difference between the largest and smallest values in the data, then approximate the width of then the approximate width of a class is obtained by dividing this difference by the number of desired classes. So like our data, suppose our data went from 801 and the largest piece of data was 2000, and we decided that we wanted 6 classes. So then what should the width be? So it has to be the distance between 800 and 2000, so that's what, 1200. And then we want to divide that into 6 classes, so that's 1200 divided by 6. So each class should have a width of 200 if they're all going to be the same size. Okay, so you could do that here. You could find the lowest and the highest, which turns out to be this, and they say suppose we want to have 5 classes, then it's going to be this number divided by 5, which is about 4.8. Now we round this approximate width to a convenient number, say 5. So we don't want to use 4.8. So we'll have the class widths as 5. Okay, and I think the rest of it is fairly straightforward, and you can go through this. This F1, F2, we denote the frequencies of the 5 classes. So here, or let's say here, where was it? Here. These frequencies, so 5 to 9 is one class, 10 to 14 is the next class, 15 to 19, 20 to 24, 25 to 29. These are the classes. And we had 3 in this interval, 6 in this interval, 8 in this interval. So these are called the frequencies, and they're denoted by, this is the first frequency, so this is denoted by F1 here. And this is the second frequency, so this is denoted by F2 here, and F3, and F4, and F5, and so on. Okay, now if we add up all the Fs, that is, if we add up all these numbers, we should get the total amount of data that we had, right? So they say if you add them all up, you should get 30. Okay, a little bit more here. Okay, let's break this video up, and we'll go to this next. Relative frequency and percentage distributions.